Once our experts map the business process and carefully identify business and technical targets, we design and deploy a business and technical glass table using Splunk ITSI. This is a business glass table. It has been designed to allow different audiences to take advantages of a single end-to-end representation. The outline sections represent the input and output applications of this particular flow, a high-value payments platform. This is the core payment engine, where the lifecycle of all payments can be monitored. Note, there are technical and business components. We also added sections for the straight-through processing rates, payments cutoff, and a high-level technical view of the payment engine. This is the technical glass table, a detailed technical view of all components supporting the payments engine. Here we have visibility of the overall health score of the servers and the databases, the health score of the end-to-end applications, and inter-process messaging queues are also monitored, as well as any interface errors that might occur. Additionally, we added a section for file feed monitoring, alerting on late arrivals, long-running processes, and errors. Batch job monitoring has been included in this technical glass table, as well as the health scores of the payments, engines, links, and gateways, and front-end websites. This is the Service Analyzer view, where all defined services and KPIs can be found. These are services. They can be business or technical, and the health score is calculated based on their associated KPIs. As an example, this is a technical service related to the GFC gateway. It contains only one KPI which measures the availability of the gateway. These are the KPIs which drive the health scores of all services. The same KPI can be applied to one or more services. We can also apply weighting to the KPIs which will be used in the health score calculation. Scenario 1. GFC gateway down. The GFC gateway, responsible for routing messages between the payments engine and the booking and funds release partner application, goes offline. As a result, payments backlog will start to form in the funds release booking stages. The inactivity period KPI will also breach its threshold as payments cannot be booked or released. The platform is in a healthy state when suddenly the GFC gateway goes down. The inbound and outbound links connected to the gateway will also display a red rag status, as well as the messaging queues trying to reach the engine. The technical glass table will display the outage. As a result of the outage, email alerts will be sent to predefined individuals or distribution lists. Notable events will be created for tracking. A bottleneck will develop in the booking and funds release stages as payments cannot process any further. This will cause the inactivity period KPIs to display an amber or red rag status, both from a booking and completion perspective. Once the gateway is back online, the bottleneck will disappear. Scenario 2. High capacity. A third-party application is demanding an unusual amount of processing power, raising the CPU usage rate to 100% of its capacity. As a result, the payment engine will be affected and payment processing will become slower, causing queue bottlenecks. The platform is once again working as expected when the CPU usage dial jumps to 100%. As expected, the technical glass table also displayed the event on the top left corner box, dedicated to server health. Even though there's nothing wrong with the payment engine itself, it is now struggling to process the payments at the same speed as it was before the incident. You will see bottlenecks forming in most of the queues, triggering alerts and creating notable events for tracking. This event could easily be overseen as an extraordinarily busy day, but since we have an end-to-end visualization, we know immediately a technical issue may be the culprit. Once the technical support team fixes the issue, payment processing speed will normalize. Scenario 3. Slow repair. According to the agreed targets, all payments must be repaired within 15 minutes during business hours. In this scenario, the repair queue volume will be within the acceptable threshold, but some payments have been waiting manual repair for a long time. Payment processing is progressing normally, at an average speed when the glass table displays a red alert for some items within the repair stage. Even though email alerts will be generated and notable events created, we can easily check which payments are waiting for manual repair just by clicking on the alerted metrics box. A drill down view will appear with the list of affected payments. This can save a lot of time for the business when prioritizing and handling incidents. Scenario 4. Payment cutoff. As defined in the agreed target, all payment types must be processed by their respective cutoff times. In this scenario, the CHAPS cutoff time is approaching and the number of payments still being processed is above average, breaching the predefined threshold. The time is now 15:30 CET and we're only 15 minutes away from the CHAPS cutoff time. The platform is processing payments normally, but since today has been an extremely busy day, the number of pending payments is above average and an amber rag status has been raised. Even though email alerts have been sent to the relevant teams and notable events created for incident tracking, it will be great to see which CHAP payments are still pending. No problem. Just click on the alerted metric and a drill down view will display a list of all pending payments. Drill downs can be created for all stages, as long as the data is accessible. Once the backlog returns to the average volume, the alerts will disappear. These are just a few examples of how powerful technical and business processing monitoring can be when combining the power of Splunk ITSI with AI's methodology.